Systems of equations by substitution. So this is the second method that we'll be learning. So yesterday or the day before we talked about graphing. Remember, it's where the two lines intersect. That's your solutions for x and y. Okay, that doesn't always work as well because sometimes you'll have fractional answers and that's really hard to get an exact answer when you're graphing, right? So we don't always get exact points when we find the intersection of those two lines. So these next two lessons we're going to learn, or these next two methods, substitution and elimination, we won't learn elimination today, but these are probably the most efficient ways to solve a system of equations. Okay, so what you want to do first, okay, your very first step is to make sure in one of your equations, there is one variable that is solved for. Okay, it's by itself on one side of the equal sign. So in this case, in number one, it's happening for both of ours. Okay, and what this is saying, y equals 6x minus 7. 6x minus 7 is the substitute for y. Okay, so in the second equation, I'm going to take y out and replace it with its substitute. Okay, it's just like a sports game, right? I'm on the court, right? And Sarah is my substitute. Well, I'm coming off the court and Sarah's coming in for me, but everyone else remains exactly where they are, right? So it's the same thing, right? So the substitute for y on the court is 6x minus 7. Okay, so y is going to come off the court and 6x minus 7 is going to take its place and everything else there is going to stay the same. So instead of having y, I'm going to have 6x minus 7 equals, and then the rest of the other equation, so negative 8x plus 21. So now I have an equation in one variable, right? We know how to solve for x. We know how to get x by itself. So I'm going to add 8x to the other side because we want to get x alone, right? So I get 14x minus 7 equals 21. And then we want to get 7 to the other side. So I'm going to add it. So I get 14x equals 28. Right, we divide by 14, so x equals 2. So right now I have one of my solutions, right? X equals 2. Well, we need to figure out y. So what you're going to do is pick either this equation or this equation. It doesn't matter which one you do, and you're going to plug in x equals 2 for x. Okay, and then you're going to solve for y. I'm going to do it in a different color. So I'm just going to pick the top one. Again, you could pick the bottom one if you want. It'll work for both. I'll actually show you that. So if I plug in x equals 2 in the first equation, I get y equals 6 times 2 minus 7, which equals 12 minus 7. Sorry, I just gave you the answer. 12 minus 7, so y equals 5. Okay, so there's my second solution. Now if I plugged in x equals 2 in the second equation, so y equals negative 8 times 2 plus 21, I get negative 16 plus 21. So again, I get y equals 5. So again, it doesn't matter which equation you plug it into to get your second solution. And remember, systems refers to graphs, okay? Systems of linear equations. So when I get my x and I get my y, I'm actually finding an ordered pair. So we write our solution as an ordered pair. Remember, it's x comma y. So 2 comma 5 is how we'll write our answer. Again, if you write it as x equals 2, y equals 5, I do not mind, but just know that the answers are usually written as an ordered pair. Okay, so I'm going to do it again in number 2. So I have y equals 8x minus 2. So 8x minus 2 is the substitute for y in the second equation. So I'm going to take y out. Instead of having y, I'm going to write the substitute. So it's 8x minus 2 equals negative 2x minus 2. Okay, now I only have one variable, which I can solve. So I'm going to add 2x to both sides to get x by itself. So I get 10x minus 2 equals negative 2, and then I'm going to add 2 to both sides. So 10x equals 0. Divide by 10. So x equals 0. Now that's my first solution. Again, it doesn't matter which one you choose to plug into. Okay, I'm going to plug it into the second one just because. Okay, so y equals negative 2. Now instead of writing x, I know what x equals, so I'm going to replace that with 0 because x equals 0 minus 2. So 0 minus 2, so y equals negative 2. There is my second solution, and we write it as an ordered pair, so 0, comma, negative 2 is the final answer. Okay, now here, in number 3, not both of them are equal to y, which is fine. Okay, I still have one equation where one variable is solved for. That's all I need. One equation, one variable by itself. Okay, so it's saying that the substitute for y in the other equation is negative 6x minus 18. Again, wherever I see that y, I'm replacing it with the substitute. Wherever y is on the court, right, that substitute is going in that position where that person was. So in this equation down here, I'm taking y out and replacing it with the substitute that we have. So everything else stays exactly the same. So it's negative 2x minus 4, but now instead of putting y, I'm putting negative 6x minus 18 equals 6. Notice everything else stayed exactly the same. I still have the negative 2x, I still have the equal 6. Now the reason why I'm putting this in parentheses is because it's negative 4 times y. That's what negative 4y means. There's a multiplication in between. So it's actually negative 4 times the substitute, which is now negative 6x minus 18. Now remember, when you have something outside of parentheses, you have to distribute. So the negative 2x stays the same. I do negative 4 times negative 6x, that's positive 24x. And then negative 4 times negative 18, which is 72, and equals 6. Okay, remember our next step is then to combine like terms. Like terms are only on the same side of the equal sign. So I get 22x plus 72 equals 6. Then I'm going to subtract 72 from both sides. So 22x equals negative 66. Now I'm going to divide by 22. And x equals negative 3. Again, there's our first answer. Does not matter which one you plug x into. Now, I'm going to plug it into the top one because y is already solved for, so it's going to make it much easier to find my solution for y. Okay, but you could plug it into the second one that's underlined in pink. You'll get the same thing. So y equals, again, I'm going to replace x with negative 3 because that's what we decided x equals. So y equals 18 minus 18, so y equals 0. Okay, there's my second answer. Again, as an ordered pair, that's negative 3, comma, 0. Okay, number 4. Now this one is still the same. It's only now x is solved for instead of y. Okay, so I have x all by itself right here. So it's saying now x has a substitute of negative 3y minus 7. So in the other equation, do not replace it back into the same equation because then you won't get an answer. Okay, everything will cancel out. So in this equation, I'm going to plug in the substitute for x right there. So x is coming off the court, right? I still have 5. But instead of x, I'm now replacing it with the substitute, negative 3y minus 7. Remember, it's 5 times x, so it's going to be 5 times whatever the substitute is. Okay, everything else stays exactly the same. So plus 5y equals negative 15. So I'm going to distribute 5 times negative 3y, that's negative 15y. 5 times negative 7, that's negative 35, plus 5y equals negative 15. Okay, combine your like terms, again on the same side of the equal sign, so negative 10y minus 35 equals negative 15. Add 35 to both sides, so negative 10y equals 20, divide by negative 10, so y equals negative 2. Okay, now I have a solution for y. I need to plug it into either equation to get an answer for x. I'm going to plug it into the second one because x is already solved for, again, making my life a little bit easier. Okay, so x equals negative 3 times negative 2, right? I'm replacing y with negative 2 minus 7. So x equals 6 minus 7, so x equals -1. Remember, write your answer as an ordered pair, so -1, comma, -2. Okay, so number 5 is a little bit different than what we've been doing, right? We are looking for an equation that is solved for a variable. Okay, I need a variable that's all by itself so I know what I'm substituting. Okay, well, this one doesn't have that. Now, when you're solving for a variable, the last thing you want to do is deal with fractions, right? I know you guys hate fractions, so what I'm going to teach you is a trick. Okay, so if you follow these rules, you won't get fractions, right? So what you're going to do is you're going to be looking for a variable, x or y, in both equations and find the variable that does not have a coefficient, right? It does not have a number in front of it. So now if you're looking at this equation, hopefully now you're identifying that x is that variable, right? X does not have a number in front, so when I solve for x, I am not going to get a fraction. I'm not going to have to deal with that when I'm solving this equation. So what I'm going to do is solve this equation for x. Okay, that's always your first step. If you don't have an equation solved for a variable, you have to do that for one of your equations. So I'm going to rewrite this over here. Okay, I need to get x by itself, right? You ask yourself what's on the same side as x. Well, that's 8y. So the opposite would be to subtract 8y. So I get x equals 16 minus 8y. Okay, once you solve that equation for a variable, cross that equation out, because I don't want you plugging that back into the equation you just solved for, because everything's going to cancel out and then you're going to get confused and it's not going to work. Okay, so what you've just done is found a substitute for x, and that substitute is going to replace x in the equation we did not touch. Okay, so I didn't touch that bottom equation, so that x is coming off the court, right? That one is coming out of the game, and I'm replacing it with the substitute 16 minus 8y. So I'm going to put 4. Remember, it's 4 times, so 4 times instead of x, it's 16 minus 8y plus 4y equals 8. Okay, then remember we distribute, so I'm going to be solving for y now, so I get 64 minus 32y plus 4y equals 8. Okay, combine your like terms. So I get negative 28y plus 64 equals positive 8. Okay, subtract both sides by 64. So negative 28y equals negative 56. Divide both sides by negative 28. So y equals positive 2. Okay, so I have one of my solutions right now. Again, now you have an option. You could plug in y into the equation you just rearranged right here, this top equation, or this equation right here. It does not matter. You will get the same answer for x. Now I am going to plug it into this one right here, because x is already solved for. Again, it makes my life a little bit easier. So I'm going to put x equals 16 minus 8 times 2, right? I'm replacing the y with the 2. So x equals 16 minus 16, so x equals 0. There is my second solution. So I get 0, comma 2 as my final answer. Okay, number 6. Again, I'm looking at the equation. I'm deciding what variable should I solve for. Okay, well, I found a variable that does not have a coefficient. That's that y right there, and it's going to make my life a lot easier. So I'm going to solve that over here. So I'm going to subtract both sides by 4x. So y equals 13 minus 4x, or you could put negative 4x plus 13. Okay, and then I'm going to cross that equation out because I don't want to plug that y back in to the equation I just solved. Okay, so this is my substitute for y, 13 minus 4x. And now I'm going to replace y in that second equation that I haven't touched. Okay, so negative 6x minus 4. Now instead of y, I'm replacing with the substitute. 13 minus 4x equals negative 2. So negative 6x minus 52 plus 16x equals negative 2. Okay, combine your like terms. So 10x minus 52 equals negative 2. Add 52 to both sides. So 10x equals 50. Divide by 10. So x equals 5. Again, there's our first solution, and then I am going to plug into any equation I want. I'm just going to plug it into this equation right here because y is already solved for. So y equals 13 minus 4. Instead of putting x, I'm putting 5 because I know x equals 5 now. So y equals 13 minus 20. So y equals negative 7. Okay, there's my final answer. Again, write it as an ordered pair. 5, comma, negative 7. Okay, last few. So I'm looking at my equation. I'm seeing x is all by itself, as in it doesn't have a number in front of it. I want to get it by itself. So by doing that, I'm going to subtract both sides by 2y. So x equals 3 minus 2y. Cross this equation out so I don't plug it back into that. Please get in the habit of doing that because a lot of you will try to re-plug it back in. Do not do that. Okay, so what I'm going to do is replace the substitute for x that's on the right side of the equal sign. Okay, x is coming out of the game. All right, I'm taking x out of that first equation I haven't touched, so negative 2. Now instead of x, it's going to be 3 minus 2y minus 4y equals negative 6. Again, everything from that top equation stays exactly the same except for replacing that x. Okay, now I'm going to distribute. So I get negative 6 plus 4y minus 4y equals negative 6. Okay, now I'm going to combine my like terms. Notice that my y's cancel out, right? 4y minus 4y, that's 0. So I get negative 6 equals negative 6. Now, hopefully this kind of looks familiar to you guys. Remember, when you solve an equation and your variables cancel out, special things happen. So when this happens, your variables cancel out and both sides equal the same exact thing. Remember, that means, well, it used to mean all real numbers, but now we're talking about a graph, right? So this is going back to the graphing notes. Okay, when it ended up being the same line, it wasn't all real numbers. What we have to say in a system is infinitely many. Again, we cannot say all real numbers because it's only the x's and y's that lie on the line, okay, and not all x's and y's would make both of these equations true. Okay, so in this case, we say infinitely many, again, because both sides equal the same thing. They both equal negative 6. And sometimes it'll be different numbers. It doesn't always have to be negative 6, doesn't always have to be 0. Okay, it'll always be different. Now with number 8, you could either solve for x or you could solve for y, but if you solve for y, just be careful. You're going to have to divide everything by negative. I'm just going to solve for the x, so it makes my life a little bit easier. So I'm going to add y to both sides to get x alone. So x equals y minus 2, or negative 2 plus y, okay, and then cross this equation out. Do not use it again unless you're finding your second solution. So here's my substitute for x in the second equation. So I'm taking x out of the game. So I get negative 8 times y minus 2 instead of putting x, right, plus 8y equals negative 5. So everything else stayed the same. Now I'm going to distribute, so negative 8y plus 16 plus 8y equals negative 5. Combine your like terms. Notice that these are also going to cancel out, so I have 16 equals negative 5. Now think back, what would happen when your variable would go away and two numbers do not equal each other, right? That means no solution. So no variables, numbers don't equal the same thing, then it's going to be no solution. Okay, so 7 and 8 are our special cases. Okay, so keep that in mind. Your variable cancels out. It's either going to be infinitely many or it's going to be no solution. It just depends on what's on both sides of the equal sign. Okay, so what I want you guys to do now, I don't know if all of you will do this, but I would like you to hit pause, and I would like you to attempt the U tries, okay? And then I will walk through my work. Once you hit play, you'll see my work, and you can check yourself compared to mine, and then you'll see if you kind of have a grasp for how to solve equations by substitution. Okay, so hit pause now, do the U tries, hit play, and then I'll explain where to go from here. Okay, with number 9, both of these are solved for y, so they both have a substitute, but I'm just going to say that this is the substitute for y in this bottom equation. Okay, so I'm going to take y out of here. I'm going to replace it with 3x minus 14 equals negative 6x plus 22. We want to get x by itself and add x. I'm going to bring 14 to the other side, numbers on the right side, variables on the left. So I get 9x equals 36 divided by 9, so x equals 4. Okay, there's my first solution. Again, you could plug in x to either equation. I'm just going to do it in this top one right here. I'll do it in another color. So y equals 3 times 4 minus 14. So we get 12 minus 14, so y equals negative 2. So we get 4 comma negative 2 as my final answer. Okay, then with number 10, so they're giving us a substitute for y, right? So in this equation up here, I'm replacing y with the substitute. Everything stays the same. So negative 7x minus 3, but now it's going to be negative 2x minus 5 equals 19. Negative 7x, distribute negative 3, right? Your sign should be changing, so that becomes positive 6x, positive 15 equals 19. So I get negative x plus 15 equals 19. Subtract 15 from both sides, so negative x equals 4, right? Divide by negative 1, so x equals negative 4. Now there's my first solution. Okay, I want my second solution. I'm going to plug it into either one. I'm just going to do it into this one, but you'll get the same thing if you plugged it into the top one. So y equals negative 2 times negative 4 minus 5. 8 minus 5, so y equals 3. Okay, so negative 4 comma 3 is my final answer. Okay, hopefully in number 11 you identified that x would be the easiest variable to solve for because there's no coefficient. Okay, so when I solve for x, I should get x equals 3y plus 31, and then I'm going to cross this equation out. Okay, don't use it. Now I'm going to plug in my substitute for x in here. Okay, so x comes out, I have negative 3, now 3y plus 31 instead of x, plus 9y equals negative 93. So I get negative 9y minus 93 plus 9y equals negative 93. My y's are going to cancel. Negative 93 equals negative 93. Okay, so this is true. So I'm going to put infinitely many. Again, not all real numbers because not all these answers lie on the line. Okay, number 12. You could have chosen negative x, you could have chosen x, it doesn't matter. I'm going to solve for this x, so when I do, I get x equals 2 plus 2y. Okay, so I'm going to cross that equation out, and I'm going to replace x with the substitute right here. Okay, beware of that negative, so it's going to be negative, but negative the entire thing. So it's going to be parentheses 2 plus 2y with the negative outside. It's just like multiplying a negative 1, right? There's an invisible negative 1 in front of the x. Plus 2y equals 6. So negative 2 minus 2y plus 2y equals 6. These cancel out. Negative 2 does not equal 6, so then we say no solution. Okay, last but not least, number 13. Again, y would be the easiest to solve for in this situation, so I'm going to add 4x to both sides. So y equals 4x plus 4. Cross this out. I have a substitute for y, so I'm going to replace it in the equation I have not touched. So negative 2x minus 2 times 4x plus 4, right? Instead of y, it's 4x plus 4 equals 2. So negative 2x minus 8x minus 8 equals 2. So I just distributed. Then negative 10x minus 8 equals 2. Add 8 to both sides. So negative 10x equals 10. Divide by negative 10. So x equals negative 1. Okay, now plug x into any equation. I'm just going to do it in this one in purple. Okay, so y equals 4 times negative 1 plus 4. Negative 4 plus 4. So y equals 0. Okay, and then our ordered pair would be negative 1, comma, 0.